So greetings of the day. Today we are going to see why 5G has uh, a stringent requirement of a very high speed data rate, and there is one more requirement is there your battery life is your device battery life, mobile battery life should be as much high as possible. I think 14 days or so they are given. So how they are achieving that we are going to discuss now. Okay. So first we will talk about why 5G proposed with a very high data rate. Okay, that we will discuss. That is the fundamental thing. Um, so see, in general, radio frame will have 10 millisecond. Okay, radio frame will have 10 millisecond. Let me project. Okay, 10 millisecond, and in that one 10 millisecond, it will be divided into 10 different subframes, like 1 millisecond subframes. Okay, so this subframe will be subdivided into slots. Okay, slots. These subframes will be subdivided into slots. Basically, slots, for slots is this subdivision is frame to radio frame to subframe subdivision is straightforward. It is quite common because you will have frame as 10 millisecond. Each subframe will be 1 millisecond. That is quite common between even LTE and 5G. Okay, the where it gets different is that, see here in in this slot, where this is where we are getting this is where this concept of high data rate being applied, and low latency, and many things. Okay, now let's say one by one. Okay, so for example, if we are using subcarrier spacing as 15 kilohertz, then it will be one slot alone, because 15 kilohertz has the 1 millisecond slot duration. Therefore, the number of subframe and number of slots will be same. Okay, but if you are applying 20 30 kilohertz, okay, 30 kilohertz, in that sense it will become how much it will become. It's actually slot duration is 500 microsecond. Then what happens is you will have a 2 slots. That's why it is 2 slots. Okay, similarly it's so how there is a commonality between these two. See how they are arriving, right? So 2 power n, so into 15 kilohertz. Okay, 15 kilohertz. Okay, so how this n n decides the number of slots per subframe. Okay, so for 15 kilohertz it should be 0 and 0, which means subframe and slots are same. For 30 kilohertz it will become 1, because 2 power 1 2 into 15 is 30. So 1 means what? So one additional two slots will be there. Similarly it keeps on going. So this is how this subcarrier spacing divided categorized by this one, 2 power n into 15 kilohertz. Okay, so 15 kilohertz is the base one subcarrier spacing, because okay. And okay, now the picture is, now the question is, okay, how this help in high data rate. Okay, now okay, for example, you have 2 slots. Let us take 30 kilohertz case. Okay, 2 slots. Okay, each slot will have 14 symbols. Okay, here we are in 5G, you might be know that 14 symbols. Okay, OFDM symbols. We are using OFDM. I think orthogonal OFDM. I think yeah, I think exact OFDM. It's not only orthogonal, some more orthogonal is there. So 14 symbols are there. Okay, so each symbols will be sent. The capacity of each symbol is dictated by the modulation scheme. Okay, 14 symbols will be sent. Okay, in one subframe, for example 30 kilohertz case, 1 millisecond, what I am sending? 28 symbols. 14 plus 14, what? 28 symbols. Okay, so now this is the one straightforward answer for high data rate is this one. Okay, If you are using subcarrier spacing as 14 symbol, 14 no 24 28 symbols, okay, 28 symbol, okay, 1 millisecond you are sending 28 symbols. The next straightforward answer is, so next straightforward answer is that modulation scheme. Okay, how modulation scheme is important, because you can see here the graph is like, signal to noise ratio, that's okay. This is capacity for different modulation scheme, how it is improving. You can see here that for QPSK it's very low data rate, whereas 1024 QAM it is very much high data rate, almost 5 times. Okay, I think more than 5 times. Okay, how it became? Because see, in QPSK you will have only 2 bits to transmit per symbol. Okay, I was talking right. So so 14 symbols are there. Each symbol, number of bits will be transmitted in each symbol will be dictated by this modulation scheme. Okay, will be dictated by this modulation scheme. Okay, so number of bits per symbol is dictated by this modulation scheme. If you are using QPSK, you will be sending only 2 bits. Okay, and if you are using 16 QAM, you are going to send 4 bits. 32 QAM, it is going to be 5 bits. 64 QAM, you are going to send 6 bits. Similarly, say 7 bits, 8 bits, like that. Okay, and so on. Okay, so what happens is, see, 14 symbols. If I am using 1024 QAM or for example 32 QAM. Okay, so I am going to use 2 power 15 is the 2 power 5 is the 32, which means 5 bits I am going to send. So 5 bits into 5 into 14, it will become 70. Okay, so 70 bits will be sent in half millisecond. Okay, similarly 20, so 70 plus 70, 120, 120, 140 bits will be sent in 1 millisecond. So when some data. Okay, so and another concept is the RB concept that we will discuss in some other presentation. Like resource, it will not be sent just like that bits. Okay, it will be sent as resource blocks. Okay, the basic element is resource element. Okay, that is basically one BRB. So that is one more frame structure is available that we'll discuss in separate topic. Like there is one graph is available, like frequency domain and versus time domain. Okay, so at each symbol time, so what, how many subcarriers I'm sending. So means subcarrier means what? So one PRB consists of 12 subcarriers in case of if I'm using 15 kilohertz. If I'm using for 30 kilohertz, it will be 6 subcarriers, like that. Okay, so total subcarrier PRB is 180 kilohertz. Okay, so 180 kilohertz can be that can be allocated like this. Okay, so this is straightforward answer for data rate being high for 5G. Okay, so one answer we got. It's one of the one of the reason why we get high data rate. Okay, there are a number of reasons. Okay, there is I think that's why I mentioned in the some of the my presentation is that, see, throughput is directly proportional to bandwidth. Okay, that's what we have discussed now. Okay, so bandwidth is high, which means subcarrier spacing, and bandwidth is high. Okay, second is that modulation scheme. Okay, modulation scheme, number of bits being handled. The another one is that is SNR. This is the crucial parameter that I want to discuss. So why we are having long life. Okay, that also SNR is obviously improving the bandwidth, like throughput capacity. Why? Because see, when you are sending a high data rate, okay, then power consumption will be too high. Okay, so SNR should be very careful, because we are dealing with high bandwidth, large bandwidth, not the narrow bandwidth as like 2G, 3G and all. So we are dealing with high bandwidth. So maintaining SNR is too difficult, because when you say your SNR is fine, then you will not be blur will be very low. If SNR is very poor, then there is no point in having just bandwidth. Okay, you will be sending data, but it will not be received. So many NACs will be coming. So negative acknowledgement will be coming. You keep on resending that data, so the net throughput will be, it will not be that good as what it should be. So that's why SNR is very, very, very important. Okay, so though we achieve very high data rate using these symbols and all this blah 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 blah. Okay, so I know by employing the high modulation scheme, and we are able to get a very nice data rate. But so once SNR is poor, then we cannot achieve. So in order to improve SNR, what they have done in 5G is that, I think we have discussed in the one of the slide, like I'm sorry. So beam, okay, beam forming. So there is a two answer for this. One is it improves SNR. The another is that it will improve. There are three advantages with this beam forming. Okay, one is improve SNR. Second one is edge cell coverage rate. Edge cell data rate, high data rate at the edge cell as well. Third advantage is that straightforward advantage. So third advantage. There are numerous advantages, but third advantage is that battery life of your device mobile will be very much higher. How? That we will discuss now. Okay. So first point, SNR will be very much high. How? See, when you have a cell coverage, okay, right? So for example, let us go to previous slides. Okay, introduction to 5G. Okay, so you have a cell coverage. Okay, cell coverage. You are sending for example 44 dBm of power. Okay, to entire cell. Okay, so which means 44 dBm power. The what you will get in this position? It will be 44 dBm of power is being distributed through beam width is so high, which means when a beam width increases, gain decreases. That is what we studied in antenna perspective. Okay, so here also it hold good the EM concept, because see, it is as simple as that. So you are having you are having power. Okay, you want to cover one particular point. It will be for example, you are using laser beams. Okay, so for example, okay, so you are sending you are directing your entire power to a particular direction. Okay, but if you want to same power will be, if it is distributed large area, what happens? The net power received by these devices will be very much low. Okay, that's why we are not having edge cell coverage will be very, very poor in these networks up to 4G. Okay, and so that's why cell coverage, SNR, how they are improving SNR in the 5G. So that is that. One is beam forming approach. Okay, for example, okay, I'm having 5 devices in the particular direction. Okay, Okay, so I will send only 5 beams. Okay, which is of high power, because you are having you are sending such a narrow beams. Okay, so the same power, imagine here, see, same power, for example some 44 dBm, you are distributing this much area. Instead you are distributing same 44 dBm power in terms of 5 beams, for example 5 beams. Okay, 5 beams, what happens? In that particular direction alone you are using your power, you are directing your power, instead of just simply radiating to the entire cell area. Okay, what you are doing, see, you can see that, for example, if you are transmitting, for example, 120 degree here. Okay, 120 degree here, what net degree will be? It will be very much less, because maybe 20-30 degree, because 5 devices, each each beam will have beam width of, for example, 5 to 7 degree. So 5 beams, it will be around 30 degree. Okay, so total 30 degree net effect. Okay, now we cannot go in that way, but still. Okay, so what you are sending? You are sending your entire power in terms of 5 beams. Therefore, so what the signal will be received by the UE will improve. Therefore, the SNR will be improved. Okay, that is answer about the first advantage. Okay, first advantage of this beam forming. Second advantage, what I mentioned. Okay, so edge cell coverage. Okay, edge cell, high data rate at the edge cell. See here, the edge cell, when you or a mobile will when it approaches the edge, okay, what happens is it will consume a lot of power because try to maintain the link, okay, sustain the link. So that time you might have experienced voice call will go because it will take very low bandwidth, but you will not be able to browse it because SNR is very poor. So that we avoid here because for example, here the beams are decided based on the CSI, channel state information reference signal, and channel state quality, RSRP, RSRQ, and SSB. Several parameters are being exchanged here and there. Finally, it decides it ensure that the UE able to receive very high power, very good SNR. Otherwise, it will keeps on rewinding. I might have mentioned in the previous my presentation, like a beam forming, beam tracking, beam refinement, and initially what it will do in beam peak search it will happen. Okay, so that is on in previous I have mentioned that. So beam search, okay, beam peak search. Then it will what will happen? It will adjust the beam peak search. It will refine the beam. Finally, it will once the beam locked with the UE device or mobile or laptop, whatever it may be, then what will happen? Beam tracking will happen. Okay, if device moves, okay, this beam will follow that. Okay, that's what is the beauty of this 5G beam forming technique. Okay, so here what we are doing? So we are sending the power, very high power at the edge, whether your device at the edge of the cell or inside the cell, it doesn't matter. Okay, because the beam will adjust the power accordingly. Because we cannot send too much power here because then beam coverage will see that beam coverage area or else in other words it is beam width. So beam coverage area will be dictated based on the mobile position because it will read the RSRP position, RSRP values, RSRQ values, channel state information values, channel state reference signal values, and channel state quality values. Based on that only it will generate the beams. Okay, so the beam, whether your device at the nearest to the tower or edge at the edge of cell, doesn't matter. So that's why we are getting very high speed at the cell edge coverage, whereas here it's a common thing. Okay, so you will not be any special because when you are nearby you will be able to access internet very fast manner. When you are approaching cell edge, what happens? Your SNR goes down, then therefore the data rate will goes down. Okay, so let me summarize before we move on to next topic. So we just saw that, okay, how data rate being improved. Okay, how data rate being improved. Okay, based on by employing the higher subcarrier spacing and modulation schemes, different higher order modulation schemes. Next, what we discussed, so the symbols we discussed. So in each symbol how many bits are data transmitted, that is dictated by the modulation schemes, what modulation scheme we employ. Okay, and number of slots in the subframe is dictated by this subcarrier spacings. Okay, how it is evaluated? 2 power n into 15 kilohertz. Okay, based on that, subframe will be so 2. So this 2 will be number slots for so this 2 power n is the number of slots in the slots per subframe. Okay, so if you are if you are applying 15 kilohertz, it is, so if you are, for example, 2 power n into 15 kilohertz, 2 power n will become 0. That's why 2 power 0 is 1, so that's why it's 1. Okay, 1 slot. So for 30 kilohertz, 2 power 1. Okay, 2 power 2. Okay, sorry, 2 power 1. Yeah, 2 power 1. Okay, n will become 1. 2 power 1 is 2. 2 into 15 is 30. But what is the value here? 2. That's why it is 2. If it is 60 kilohertz, it is 2 power 2. Okay, n will become 2. So 2 power 2 is what? 4. We are getting 4. So 4 into 15 is 60 kilohertz. What we are getting is same. Okay, so this is how it is calculated. So then we saw that, okay, so what are the key enablers of 5G? So we mentioned that there are 3 advantages, like in order to achieve the higher data rate, we need bandwidth, the SNR. So how SNR being improved in the 5G, that we discussed. Okay, and those because cell coverage and edge cell data rate, yes, how SNR being improved, edge cell data rate, how it is being improved. Those things are we have discussed. Okay, now the last point is that how UE battery life improves. Okay, that question will come into. So how they are ensuring that a very long life, it's not unimaginable when compared to the 4G or 3G. Okay, because we are running sort of battery in 4 or 5 hours or 6 hours or 8 hours, but requirement in 5G is very stringent, because in 15 days they are talking, I think 14 days. Okay, but it not be 40 days, but at least 3-4 days, because how they are ensuring. So one thing is that, see, UE will not send the status. The one point is that you will not send the status to the network that I am here. No, it will send, I think, every 20 millisecond or even later. Okay, that's what I heard from the I saw in the some of the references. So it will not send, keep on updating. I think it will update to the network in certain interval. Then it will go to sleep. Okay, that is the one reason why we are getting very long battery life. We are ensuring, why we are why 5G is ensuring, proposing that very long battery life, how they are achieving the very long battery. Second point is that, so beam is following you. Okay, you are not going to track, you are not going to wait for um, power. Okay, so for example, if in the 4G case, what happens when you approach a cell edge, what happens is, so there are two processes will happen. Okay, so UE will try to receive the signal and decode it. So then that time low noise amplifier will play a major role, and low noise amplifier, what it will do, it will keep on improving the signal, and then it will gives you, and the processing, a lot of processing will happen, so that consumes a lot of battery. Okay, second thing is that if UE want to communicate with the cell tower, okay, what happens is, that time what happens is, it will try to pump more power to, in order to reach and ensure that the power amplifier will come into picture. Okay, transmitter side. Okay, so this you might have experienced, because when you travel from very long distance for more than 10 hours, okay, or 5 hours from the one place to another place, your battery will go down very easily. Why? Because obviously, so in travel you will come across, you will get come across several cell edges. Okay, so it will try to maintain the coverage, and then a lot of handover will happen, so a lot of processing is happening in your phone, so that consumes a lot of power. So when you are having smartphone, you are gone, that's all. So your power will be, that's why many people, what they will do, they will put in flight mode. Okay, or they will simply switch off during the travel. Okay, so that's the reason. Okay, but here 5G, what they are doing is that I mentioned already, so it improves SNR by having beam forming. Okay, so what happens is that, so whether you are in the edge or near, so beam forming will take care of you, because based on channel state information, so it keeps on improving the network coverage. Okay, I think in 4G also some kind of intelligence is there, but not that level of 5G, because here beam forming coming into picture, but 4G is still stuck up with the cell coverage. Okay, so what happens is, so you are you are getting enough power from the base station. You ensure that the cell coverage is having enough power, so your low noise amplifier need not work hard, a lot of processing need not be done. And so what I mentioned first is that it need not update that network that I'm here. So because based on channel state information, it will have a keep track of it. And if you are active user, okay, for example, you are browsing or something, so that time that beam will gets refined according to your requirement. Okay, when according to your movement, so what is the data rate, so you are using whether you are it will dictate, it will decide the intelligent it will has is. So if you are it will decide that you are important customer, so that it will beam will adjust automatically, ensure that, it will ensure that SNR will be very much better. Okay, so that's why we will get longer battery life. These are all the some of the reasons why we get longer battery lives. These are the some of the reasons what I mentioned is why we get higher data rate. There are many other things are there, so complex algorithms, many things are there. So that's why I thought that, okay, this point of view I wanted to share with you. So thank you all. So if you have any comments, please post in the comment box. If you liked this video, please subscribe to my channel. Thank you.